All right, let's look at the problem set. So again, if you should have the either you actually have a problem set in front of you, or you can write it on notebook paper. Um, I'd like to see you writing out the question. That would be helpful. But let's read it here. Jeffrey's first planter. Well, Jeffrey builds rectangular planters. Jeffrey's first planter is 8 feet long, 2 feet wide. Container is filled with soil to a height of 3 feet in the planter. What is the volume of the soil in the planter? Explain your diagram. All right. Well, I think I have a kind of a picture of this in my mind. This guy has a planter. Planter is um, some has some certain volume. So imagine maybe that's my planter, has some kind of volume, except the trick or the interesting piece is that it's not whatever the total volume is, it's not filled all the way up. I don't think we're going to know the total volume. It's not filled the whole way up. It only goes 3 feet up. So we have a height, but that's not the height of the total volume. Kind of cool. All right. So let's, so we read it and now we need to draw. So let's draw a planter. Let's see here. So this is like a rectangular prism planter, something like this. And let's see. So it's 8 feet long. 8 feet. And it's 2 feet wide. So here to there is 2 feet. And the height is kind of tricky. Container is filled with soil. So this whole thing is filled with soil to say there. And it's filled with soil to a height of 3 feet. So this is 3 feet. Now, what is the volume of the soil? So it's asking what the volume of the soil is inside this container, not what the whole container is. And that's good because we don't know how much, we don't know the height of the whole container. What is the volume of the soil in the planter? Okay, so volume of soil. I think it's going to be helpful if we start saying like, in our the work that we did on Friday was like volume of A, so volume of box A, volume of box B, and so on. So volume of soil equals the length times the width times the height equals, so the length 8 feet times 2 feet times 3 feet. So that's let's do 2 times 3 is 6 times 8 is 48. So it's 48 cubic feet. 48 cubic feet. So that's how much soil goes in the planter that Jeffrey built. So we would say, remember, we drew, we read, we drew, now we write. There is 48 cubic feet of soil in the planter. Okay. Oh, it's something like that. All right. So the second one, let's see. Do I want you to? Yeah. The second one, Jeffrey wants to grow. Jeffrey wants to grow some tomatoes in 4 large planters. He wants each planter to have a volume of 320 cubic feet, each one. But he wants them all to be different. Show 4 different ways Jeffrey can make these planters and draw diagrams with the planters' measurements on them. So, okay. I think that the key here is that he wants to make 4 different planters. Each one has a volume of 320 cubic feet. So the volume of planter A equals 320 cubic feet, and B equals 320 cubic feet. C, whoops, (320 cubic feet). D, also 320 cubic feet. And what are the dimensions going to be? What are the measurements that will make it 320 cubic feet? Well, so really what we're thinking is, I need 3 factors that equal 320. So let's see, what would be a good factor? How about, well, about 1 foot by 10 feet. That gets me 10, and I need 32 of those, right? 32 tens, 32. So one way would be one foot. It would be this kind of a crazy shape, but it would get us 320 cubic feet. How about, or some other factors that we multiply together to get 320? How about, let's see, 32 times 10, 2 times 5. How about 16 times 2 times 10, right? 16 times 2 is 32. Multiply that by 10. How about 32 times, let's see, instead of saying 32 times 10, let's do 2 times 5. 2 times 5. And we need one more. How about, let's see, 8 times 4 is 32. So we could do 8 times, volume equals 8 times 4 times 10. All right, so each of these is going to give us a volume. 1 foot by 10 feet by 32 feet. It's going to give us a volume of 320 cubic feet, and so on, right? So now I just need to draw them, okay? So I'm going to pause it for a second, draw these for you. All right, so I made some of the world's weirdest looking planters. This one's 32 feet high by 1 foot and 10 feet in width. 32 foot high planter is like a 3-story building. That would be kind of crazy. This one's still pretty high, 10 feet by 16 feet by 2 feet. It's funny because as I was doing them, I realized that the width on all of them, length times width times height, like on all of them, I made the width like the smallest number to, let's get rid of that. I made, well, not the smallest, but one of the smallest numbers. So 10 and 2 and 4 and 2. So all of them like are these really odd looking planters. I don't know. Probably if I were going to do it again, I would come up with different planter shapes. But anyway, all right. So last thing I want you to do is I want you to model. So now that you've watched this video, I want you to take this problem and model it in the Schoology answer. Okay, and then you can go back and do 3 and 4. You can do 3 and 4 from the problem set, and that'll make for good practice. But that's what I'm looking for in Schoology. I'm looking for a model of this. Okay.